November 22, 1922. Gosport, Indiana. A life began in a world poised on the brink of economic ruin and widespread conflict. Eugene Morrison Stoner entered existence bearing only his name. In a modest agricultural community where most households grappled with the harsh realities of the Great Depression, no one could have foreseen that this child, who would forego a college education and spend his formative years assembling aircraft components in California's industrial centers, would ultimately conceptualize the most debated and extensively utilized military firearm in contemporary history. The pencil traced its path across paper as the emerging machinist meticulously refined weapon designs he had never received formal instruction to construct. Toiling late into the nights in his Long Beach garage, following demanding shifts at Vega Aircraft Company, Stoner was intent on resolving a challenge that had confounded military engineers for decades. The objective was to devise a rifle sufficiently light for soldiers to transport through dense jungles and across rugged mountains, potent enough to neutralize an adversary at 500 yards, yet dependable enough to perform under the planet's most unforgiving conditions. According to every authority in the firearms domain, to the United States Army Ordnance Corps, and to a tradition rooted in the American Civil War, the answer was unequivocally negative. A truly lightweight automatic rifle was deemed an impossibility. The fundamental laws of physics forbade it, and the necessary materials did not yet exist. Anyone professing otherwise was either deluded or deceptive. Stoner possessed neither of these flaws. He simply had the resolve to question established premises that others accepted as immutable truths, and that very willingness would ultimately equip millions of service members, fundamentally alter modern infantry doctrines, and ignite enduring controversies. The year was 1939. Eugene Stoner had just completed his studies at Long Beach Polytechnic High School. Higher education was not a feasible option. The economic downturn had depleted his family's savings, leaving no funds available for university tuition. While his more affluent peers embarked on their academic journeys at Stanford and Berkeley, the young man sought employment at Vega Aircraft Company. He was engaged to install armaments onto training aircraft. The role demanded meticulous precision, unwavering attention to detail, and a comprehensive grasp of mechanical systems. Crucially, it also afforded him access to an invaluable resource: aircraft-grade aluminum, a material most firearm manufacturers had never contemplated for weapon construction. For generations, rifle manufacturers had relied on wood and steel, dense traditional materials capable of withstanding the explosive pressures of gunpowder and the jarring impact of recoil. The young engineer viewed these materials and perceived inherent limitations. Steel, while robust, was excessively heavy. Wood was susceptible to moisture absorption and subsequent warping. Both contributed unnecessary mass to weapons that soldiers were required to carry for extensive distances. However, aluminum, the lightweight metal employed in aircraft fabrication, offered distinct advantages. It was less dense than steel, resistant to corrosion, and, when expertly engineered, sufficiently strong to endure the operational stresses of a rifle. The prevailing obstacle was that no one had succeeded in fabricating a combat rifle from aluminum. Every prior attempt had failed. Stoner filed this observation away, intending to revisit it later. December 7, 1941, Pearl Harbor. Like countless young Americans, the 19-year-old enlisted in the armed forces. He joined the United States Marine Corps, focusing on aviation ordnance. The Corps deployed him to the South Pacific and northern China, where he spent the duration of the war maintaining and repairing machine guns, rifles, and automatic weaponry. While he never engaged in direct combat, he gained an equally significant insight for a future firearms designer. He witnessed weapon malfunctions firsthand. He observed Marines struggling with the M1 Garand, a commendable rifle that, nonetheless, proved too cumbersome for jungle operations. He noted the M1918 Browning automatic rifle, powerful but weighing nearly 20 pounds. He studied the M1941 Johnson rifle and light machine gun, innovative designs largely dismissed by military strategists as overly complicated. Every evening, after completing his maintenance duties, the young Marine would sketch potential improvements, his notebooks filled with modifications, alternative gas propulsion systems, and varied bolt configurations. His fellow Marines considered him preoccupied. They were not mistaken. By 1943, he had, in his spare time, developed 2 prototypes for a .30 caliber carbine. Neither was finalized, but both showcased concepts that would later manifest in his groundbreaking designs. The straight-line stock, which directed recoil rearward rather than upward. The streamlined gas system, negating the need for heavy operating rods. And the modular construction, facilitating rapid field disassembly. These were not arbitrary innovations, but systematic solutions to the identified shortcomings of combat arms. The war concluded in August 1945. The 22-year-old veteran returned to California and promptly sought employment in machining facilities. He was hired by Whitaker, a manufacturer of aircraft components, commencing his tenure on the factory floor. Within months, his proficiency with precision machinery led to his promotion to design engineer. It was in this capacity, leveraging aerospace manufacturing techniques, that he honed his understanding of how to machine aircraft-grade aluminum to the exacting tolerances required for firearm production. This knowledge would prove indispensable. By 1954, nearly a decade had elapsed. He had held various engineering positions while continuing to develop firearm designs in his garage. His prototypes had garnered attention from firearms specialists, but no manufacturer was prepared to invest in their production. Then, an opportunity arose that would alter the trajectory of everything. A nascent firm named Armalite, a division of Fairchild Engine and Airplane Corporation, was seeking a chief design engineer. Armalite had been established with the explicit purpose of introducing modern materials and manufacturing methodologies to the firearms industry. They comprised fewer than a dozen employees and lacked a manufacturing facility, functioning primarily as a research and development entity intending to license their designs to larger enterprises. This was an ideal setting for the self-taught engineer. He was engaged on October 4, 1954, and immediately commenced work on his most ambitious project to date. The United States Army had announced in 1955 their intention to procure a successor to the M1 Garand rifle. The new weapon was mandated to fire the standard NATO 7.62 mm cartridge, the same round utilized by most Allied nations. It was required to be reliable, accurate, and, ideally, lighter than the 9.2-pound Garand. Every prominent firearms manufacturer in America and Europe submitted proposals. Springfield Armory presented the T-44, essentially an updated M1 Garand, chambered for the new cartridge. Fabrique Nationale of Belgium offered their FAL rifle, already in service with several European armies. Both represented conventional designs, incorporating steel receivers, wooden stocks, and gas piston systems validated by decades of use, each weighing approximately 9 pounds. Armalite's submission, designated the AR-10 for Armalite Rifle No. 10, weighed 7.25 pounds. Army testing officials at Springfield Armory suspected an error in the specifications. No rifle firing full-power NATO ammunition could achieve such a low weight and maintain operational reliability. They presumed the documentation was flawed. Then, in late 1956, the rifle arrived for evaluation. The AR-10 presented a visual departure from any military rifle the testers had encountered. Its stock and handguard were constructed from fiberglass, reinforced with foam materials derived from aircraft manufacturing. The receiver was forged from a 70075 T6 aluminum alloy, the same material used in aircraft structural components. The rifle featured a straight-line configuration, with the stock aligned directly behind the barrel, eschewing the traditional downward drop. This design ensured that recoil forces propelled directly backward into the shooter's shoulder, mitigating muzzle climb. The gas system was revolutionary. Rather than employing a heavy operating rod, as seen in the M1 Garand, or a piston system, like the FAL, the design directed expanding gases directly from the barrel, through a tube, to the bolt carrier. This system, colloquially termed direct impingement, though more accurately, an internal expanding gas system, eliminated nearly 2 pounds of reciprocating metal. Initial testing reports were highly favorable. Evaluators noted that the AR-10 was the most easily controllable rifle in automatic fire they had ever tested. The straight-line design, coupled with an effective muzzle brake, rendered the weapon remarkably manageable despite firing potent NATO ammunition. Accuracy was exceptional, consistently yielding groups under 2 inches at 100 yards, surpassing both the T-44 and the FAL. Reliability proved satisfactory in preliminary trials, with the aluminum receiver exhibiting no signs of stress or failure. However, endurance testing presented challenges. The Army subjected the AR-10 to rigorous trials designed to expose any vulnerabilities. Thousands of rounds were discharged without cleaning or maintenance. The rifle endured extreme temperature fluctuations and was immersed in mud and sand. During one particular test, the composite barrel, a steel liner encased in an aluminum sleeve, failed catastrophically, resulting in an explosion. The rifle was destroyed. Army testing officials documented their findings and concluded that the AR-10 was rejected. They acknowledged its innovative attributes, its reduced weight, and its superior controllability, but determined that it would require 5 years or more to rectify the deficiencies and secure its adoption. The United States Army selected the T-44, which subsequently entered production as the M14 rifle in 1957. The AR-10 had failed, but its designer gleaned a critical lesson from this setback. The composite barrel had been a regrettable specification dictated by Armalite's president, overriding Stoner's objections in an effort to save weight. He promptly engineered an all-steel barrel for the AR-10. This redesign arrived too late for the American Army trials, but not for other prospective clientele. In 1957, Armalite licensed the production of the AR-10 to Artillerie Inrichtingen, a Dutch firearms manufacturer. Over the subsequent few years, the Dutch firm produced fewer than 10,000 AR-10 rifles, supplying them to Sudan, Portugal, and several other nations. Portuguese paratroopers who utilized the AR-10 in African colonial conflicts lauded its accuracy and dependability. French Foreign Legion troops in Chad, who acquired some through various channels, reported it as one of the finest combat rifles they had ever employed. The AR-10 functioned as intended. It had simply arrived too late and too unproven for the cautious American military procurement officers who favored conventional designs. While the AR-10 was being manufactured in the Netherlands, the Armalite engineer was already engrossed in his next project. He had definitively demonstrated that a lightweight rifle could effectively function with full-power ammunition. However, a question was gaining traction within military circles. Did soldiers truly require full-power cartridges? Post-World War II and Korean War analyses indicated that the majority of infantry engagements occurred at ranges under 300 yards. At such distances, a smaller, lighter cartridge could be as efficacious as the heavy NATO round, and soldiers could carry a significantly greater quantity of ammunition. The United States Continental Army Command issued revised specifications in early 1958. They sought a lightweight rifle chambered for a small-caliber, high-velocity cartridge. The solution involved scaling down the AR-10 design. The straight-line configuration, the gas system, the aluminum receiver, and the modular construction were all retained, but the dimensions were adjusted to accommodate a much smaller cartridge, the 223 Remington. This sporting cartridge, initially developed for varmint hunting, propelled a diminutive projectile weighing under 60 grains at velocities exceeding 3,000 feet per second. The high velocity ensured that the small bullet inflicted devastating wounds despite its minimal mass. The compact cartridge enabled a soldier to carry 300 rounds, rather than 140 rounds of NATO ammunition. The initial AR-15 prototype was completed in May 1957. When fitted with a 20-round magazine, the rifle weighed a mere 6 pounds, less than half the weight of the M14. Its overall length was 39 inches compared to the M14's 44 inches. It possessed the capability for both semi-automatic and fully automatic fire. Early assessments revealed its capacity to penetrate a steel helmet at 500 yards and a standard infantry flak jacket at 300 yards. The wound ballistics were exceptional. The small, high-speed projectile would yaw and fragment upon impact with tissue, creating wounds significantly larger than the bullet's diameter. The United States Army evaluated the AR-15 and dismissed it. They had recently adopted the M14 and expressed no interest in an alternative rifle, particularly one firing what they considered a varmint cartridge. The Ordnance Corps, the branch responsible for weapons procurement, actively opposed the new design. Some historians suggest this opposition stemmed from personal animosity. Armalite had previously rejected an offer from the Ordnance Corps to acquire development rights for the AR-10, fearing the Army would suppress the design. The Ordnance Corps had not forgotten this refusal and had invested their reputation in the M14, unwilling to admit they had selected the incorrect weapon. Armalite attempted to market the AR-15 to foreign militaries. While some expressed interest, United States foreign aid policy mandated that Allied nations utilize weaponry compatible with American military arms. Because the AR-15 fired a different cartridge than the M14, prospective international customers were unable to purchase it. By 1959, Armalite faced significant financial difficulties. They had invested years in developing the AR-10 and AR-15, but had sold very few units. The company lacked manufacturing capabilities and depended entirely on licensing fees. Fairchild Aircraft Corporation, Armalite's parent entity, resolved to divest their assets. In February 1959, Armalite sold the rights to the AR-15 to Colt's Manufacturing Company for $75,000, plus royalties on each rifle produced. It appeared that this revolutionary rifle would join the ranks of countless other firearm designs that showed promise but never achieved mass production. Colt had acquired the rights, but they lacked a military buyer. The Army remained uninterested, and no foreign military could procure it. The AR-15 seemed destined for obscurity. Then, a 4th of July barbecue intervened, destined to change everything. July 4th, 1960, a farm in Maryland. Richard Boutell, president of Fairchild Corporation and former president of Armalite, hosted an Independence Day celebration. Among the distinguished guests was General Curtis LeMay, Vice Chief of Staff of the United States Air Force. LeMay was a figure of legend within American military circles. He had orchestrated the firebombing campaign against Japan during World War II and commanded Strategic Air Command, transforming it into the most formidable military force in history. He was known for his demanding demeanor, his disdain for bureaucratic processes, and his unwavering commitment to his convictions. At 53 years of age, he was the youngest 4-star general in American history. William Mullen, a Colt sales representative, had brought an AR-15 to the gathering, hoping for an opportunity to demonstrate the rifle to any military officers in attendance. Upon learning of General LeMay's presence, Mullen prepared a special demonstration. He positioned watermelons at 50-yard and 150-yard intervals downrange. He then presented the AR-15 and several loaded magazines to General LeMay. The general, an experienced marksman, briefly examined the rifle before commencing firing. The watermelons disintegrated. The minuscule 223 bullets, traveling at over 3,000 feet per second, struck the watermelons, causing them to burst dramatically. LeMay discharged several magazines, successfully engaging targets at varying distances. The rifle performed flawlessly. When Mullen informed him that one watermelon remained, LeMay declined to fire at it, remarking, "Let us eat the son of a bitch." The demonstration concluded while the general and other party guests consumed the remaining watermelon. LeMay proceeded to ask pointed questions regarding the rifle's design, its ammunition, and its manufacturing capacity. He learned it weighed 6 pounds when loaded, a stark contrast to the 9.2-pound M14. He discovered that an average soldier could carry 240 rounds of 5.56 millimeter ammunition compared to 100 rounds of 7.62 millimeter. He was informed that marksmanship evaluations had revealed 43% of AR-15 shooters qualified as expert versus only 22% of M14 shooters. By the conclusion of the celebration, General Curtis LeMay had reached a definitive decision. He desired this rifle for the Air Force. Air Force security personnel were still equipped with the M1 carbine from World War II, a weapon considered inadequate for defending air bases against potential enemy incursions. The AR-15 would provide them with firepower comparable to infantry rifles while maintaining a lightness suitable for security troops requiring mobility. LeMay placed an immediate order for 8,500 rifles and 8.5 million rounds of ammunition, a decision made at a 4th of July barbecue based on the spectacle of exploding watermelons. A significant impediment arose. The United States Army held ultimate authority over all rifle procurement for every branch of the military. For the Air Force to acquire AR-15s, Army approval was imperative. The Army had previously rejected the AR-15 and was disinclined to reverse their decision, especially at the behest of an Air Force general. General Maxwell Taylor, chairman of the Joint Chiefs of Staff, advised President John F. Kennedy that the integration of two distinct rifle calibers into the military system would present considerable challenges. LeMay's request was consequently denied. Curtis LeMay was not one to accept defeat passively. Over the ensuing 2 years, he would embark on one of the most persistent campaigns in the annals of American military procurement. The Air Force Vice Chief of Staff submitted formal requisitions, attended numerous Pentagon meetings, and presented data from Air Force evaluations demonstrating the AR-15's superiority over the M14. He made it unequivocally clear that the Army's objections were rooted in institutional pride rather than objective assessment. In the summer of 1961, LeMay was elevated to the position of Air Force Chief of Staff, the highest-ranking officer within the service. From this elevated platform, he secured direct access to President Kennedy and Secretary of Defense Robert McNamara. He promptly requested authorization for 80,000 AR-15s to equip the entire Air Force. Once again, the request was denied. The general was renowned for his unwavering tenacity. He submitted a second request, followed by a third. Each time, Army officials obstructed the procurement, arguing for the M14's continued superiority and highlighting the logistical complications of maintaining two different calibers within the military system. LeMay countered by pointing out that the Air Force already employed a diverse array of weapons distinct from those of the Army in numerous categories. The debate persisted throughout 1961 and extended into 1962. Concurrently, events unfolding in Southeast Asia exerted increasing pressure for a more effective infantry weapon. American military advisors in South Vietnam reported that the Viet Cong, armed with Soviet AK-47 rifles, were outperforming South Vietnamese troops equipped with M1 Garands. The AK-47 utilized an intermediate cartridge conceptually similar to the AR-15's 5.56 mm round. It was lighter than NATO rifles, more manageable in automatic fire, and devastatingly effective in jungle environments. American advisors began requesting AR-15s for field evaluations. In late 1961, Secretary of Defense Robert McNamara authorized a limited trial. 1,000 AR-15s were dispatched to Vietnam for assessment by Special Forces units and South Vietnamese forces. The resultant reports were overwhelmingly positive. Special Forces soldiers affirmed that the AR-15 was ideally suited for jungle combat. Its lightness facilitated movement through dense vegetation, and its compact size made it maneuverable in confined spaces. The small cartridge allowed soldiers to carry sufficient ammunition for extended patrols, and despite its diminutive dimensions, the rifle proved highly effective against enemy combatants. The high-velocity, lightweight bullets were producing severe wounds. South Vietnamese troops, who received AR-15s for testing, adamantly refused to relinquish them, asserting that the rifle's reduced weight and superior controllability rendered it vastly more effective than their existing armaments. Some Vietnamese soldiers declared that the AR-15 gave them the firepower equivalent of 3 men. Secretary of Defense Robert McNamara was now receiving diametrically opposed assessments. The Army maintained its assertion that the M14 was superior and the AR-15 inadequate for military service. Reports from airborne units, elite commando teams, and battlefront observations in Vietnam all championed the AR-15 as a vastly superior weapon. Secretary McNamara, prompted by these claims, mandated further rigorous evaluation. In early 1962, he initiated a comprehensive comparative study pitting the AR-15 against the established M14 and the Soviet AK-47. This investigation, identified as the Hitch Report, concluded its findings in the summer of 1962. The outcome proved deeply unfavorable for the Army's entrenched position. The AR-15 demonstrably outperformed the M14 across every quantifiable metric. Personnel equipped with AR-15s possessed greater ammunition capacity, exhibited superior accuracy at targets, and found weapon maintenance considerably less burdensome than their counterparts wielding M14s. The study's implications were even more stark. It asserted that the M14 had failed to surpass the performance of even the AK-47. America's nascent rifle, adopted merely 5 years prior at immense financial expense, was revealed to be outclassed by the very Soviet firearm it was intended to supersede. The Army vehemently contested these findings, alleging test bias and conducting their own assessments to bolster the M14's perceived dominance. They argued that the 5.56 mm cartridge lacked adequate stopping power. Nevertheless, McNamara had reached his decision. In November 1962, he authorized the initial acquisition of AR-15 rifles for the Air Force and Army Special Forces. General Lemaille finally secured approval for his chosen firearms, though not the full 80,000 units he had initially sought. His unwavering advocacy had borne fruit. The initial consignment of 8,500 rifles arrived in May 1962, nearly 2 years after his initial request, at a Maryland social gathering. The firearm was subsequently designated the M16. Colt had implemented several enhancements to the original AR-15 blueprint, most notably relocating the cocking handle from beneath the carrying handle to the rear of the receiver. Production commenced with increased momentum. In November 1963, McNamara procured 104,000 rifles, 85,000 XM16E1 variants for the Army and Marines, and 19,000 M16s for the Air Force. The contract, valued at $13.5 million, was awarded to Colt on the 4th day of November, 1963. By the end of 1963, tens of thousands of M16s were being manufactured, and in early 1964, the first substantial shipments began reaching Vietnam. The Army, still harboring reservations about the new rifle, commenced replacing the M14 with the M16 in units slated for deployment to Vietnam. The improbable had materialized. A lightweight firearm firing a diminutive cartridge was supplanting the conventional, heavier rifle that military strategists had insisted was indispensable. Everything appeared optimal. The M16 was lighter, simpler to operate, and offered superior control during automatic fire. Soldiers could carry double the ammunition load. The rifle had performed impeccably throughout all official trials. And then, soldiers in Vietnam began to perish due to rifle malfunctions. Reports of M16 failures in combat started to emerge in late 1965. The rifles were experiencing extraction failures, leaving spent cartridge casings lodged in the chamber. Deceased soldiers were discovered with their weapons disassembled beside them, desperately attempting to clear jams under intense enemy fire. Marines penned letters home describing their rifles as utterly inadequate. Some troops developed such profound distrust in the M16 that they resorted to picking up enemy AK-47s from the battlefield, risking court-martial for the sake of possessing a firearm they could rely upon. Parents received correspondence from their sons detailing rifles that jammed after only a few shots. One Marine recounted, "We departed with 72 men in our platoon and returned with 19. Believe it or not, do you know what claimed most of us? Our own rifle. Virtually every one of our fallen comrades was found with his M16 taken apart next to him, where he had been trying to fix it." The rate of malfunctions was astonishing. In one survey conducted in 1967, 80% of 1,585 troops reported experiencing stoppages while firing. The M16, the rifle intended to grant American soldiers a decisive edge over their adversaries, had become a significant liability. Soldiers began dubbing it the Mattel toy, referencing the plastic toy manufacturer, suggesting it was suitable for target practice, but failed when lives were at stake. Certain units requested to be re-equipped with the older M14. Others scavenged AK-47s from fallen Viet Cong, leading to an illicit market where soldiers bartered cigarettes and other goods for captured Soviet firearms. The weapon intended to symbolize American technological supremacy had transformed into an emblem of broken trust. What had transpired? How had a rifle that performed flawlessly in trials become lethally unreliable in combat? Eugene Stoner was profoundly shocked by the reports. He journeyed to Vietnam in early 1967 to conduct a personal investigation. His discoveries would ultimately precipitate a congressional inquiry and reveal one of the most ignominious chapters in the annals of American military procurement. The rifle he had conceived was fundamentally sound. However, the Army had made alterations to it, and these modifications, executed without adequate testing, without consulting the designer, and without comprehending the underlying engineering principles of the weapon's operation, had transformed a dependable implement into a deadly trap. The initial issue stemmed from the propellant. Stoner had designed the AR-15 to utilize IMR 4475 powder, a specific type of stick propellant that burned relatively cleanly. This powder had been employed in all rifle testing. It produced consistent pressures, left minimal residue, and ensured reliable weapon function. However, the Army, without consulting Colt or the designer, switched to a different propellant. They adopted WC-846 ball powder, manufactured by Olin Mathieson, a company with close ties to Army procurement officials. Ball powder burned less cleanly than IMR powder, leaving a greater accumulation of residue within the chamber and on the bolt. It also generated slightly higher pressures, elevating the rifle's cyclic rate of fire from approximately 750 rounds per minute to nearly 1,000 rounds per minute. This accelerated cyclic rate meant the rifle's extraction mechanism was ejecting cartridge cases from the chamber at a rate exceeding its design parameters. combined with the dirtier propellant, which deposited more residue in the chamber. These factors created ideal conditions for extraction failures. Spent cartridge cases would adhere to the chamber. As the bolt attempted to extract them at high velocity, the rims of the cases would fracture, leaving the case body lodged within the chamber. The sole recourse for clearing such a jam was to insert a cleaning rod down the barrel and dislodge the lodged case, a procedure rendered impossible during active combat. The second deficiency involved chrome plating, or more precisely, its absence. The designer had stipulated that the chamber and bore be chrome-plated to prevent corrosion. Chrome plating was standard practice for military rifles intended for use in humid environments. The dense jungles of Vietnam, with their persistent moisture and limited cleaning facilities, represented precisely the scenario where chrome plating was critical. Armalite had advocated for chrome plating from the outset. Colt had specifically requested chrome plating in their communications with Army procurement officers, yet the Army, aiming to reduce costs, removed the chrome plating specification, deeming it unnecessary. The steel chambers corroded rapidly in Vietnam's humidity. These corroded chambers increased friction during extraction, exacerbating the problem of stuck cartridge cases. Ammunition stored in humid conditions also suffered degradation, with brass cartridge cases developing a patina that further increased friction. In subsequent testimony before Congress, experts would identify the lack of chrome plating as the primary contributing factor to the M16's failures in Vietnam. The third issue was the lack of maintenance training. The Army had propagated the notion that the M16 was a self-cleaning firearm, assuring soldiers that regular maintenance was unnecessary. Cleaning kits were not distributed to troops, and technical manuals were withheld. Soldiers arrived in Vietnam having fired the M16 only once or twice for familiarization, lacking any training on its maintenance and without the requisite tools for cleaning, even if they had possessed the knowledge. The rifle was not self-cleaning. No firearm is. The gas system, which channeled hot gases directly into the receiver, necessitated regular cleaning to prevent carbon buildup. When coupled with the less efficient ball powder, the absence of chrome plating, and the humid climate, this neglect of maintenance resulted in rifles rapidly becoming so fouled they ceased to function. Soldiers accustomed to years of maintaining M1 Garands and M14s, firearms capable of operating with minimal upkeep, found themselves equipped with weapons requiring constant attention to remain operational. One particularly harrowing incident, documented by the congressional investigation, involved a Marine unit engaged in intense combat. Only one Marine in the squad possessed a cleaning rod. As his fellow Marines' rifles malfunctioned sequentially, this individual moved along the line, using his cleaning rod to clear each jammed weapon. He tragically perished while attempting to clear a jammed rifle for another Marine. The investigation concluded that his death was a direct consequence of the Army's failure to equip troops with essential cleaning apparatus. The fourth complication was the forward assist mechanism. The original AR-15 design did not incorporate a forward assist, a device intended to allow the shooter to manually drive the bolt forward if it failed to seat completely. The designer had intentionally omitted this feature, adhering to a design philosophy that dictated any bolt closure failure indicated an underlying issue requiring rectification, not forceful imposition. However, Army ordnance officers, accustomed to rifles equipped with forward assists, insisted on its inclusion in the M16. The forward assist enabled soldiers to forcibly chamber rounds into fouled chambers, thereby increasing pressure on the extraction system and heightening the likelihood of jams. Tests conducted at Rock Island Arsenal had demonstrated that forcing the bolt forward could induce severe extraction failures, but the Army disregarded these findings. By early 1967, the M16 crisis had escalated into a national scandal. Concerned parents were petitioning congressmen, and newspapers were publishing reports detailing defective firearms. Soldiers were losing their lives not due to enemy action, but because their weapons had betrayed them. On the 15th day of May, 1967, Representative Richard Eichord of Missouri convened a special subcommittee to investigate the M16 rifle program. The hearings, which spanned through August 22, 1967, involved hundreds of witnesses and culminated in a report that remains one of the most damning documents in American military history. Eugene Stoner testified before the subcommittee, explaining that the Army had altered his design without his consultation. He demonstrated that with IMR powder, proper chrome plating, and adequate maintenance, the M16 exhibited a reliability comparable to any military rifle ever produced. He presented documentation proving his consistent recommendation of chrome plating from the inception of the project. He submitted test data substantiating the rifle's flawless performance with the appropriate ammunition. Colt representatives testified that they had alerted the Army to the issues associated with ball powder, but had been disregarded. They provided documentation indicating Colt's explicit recommendation for chrome plating, a specification that had been eliminated to achieve cost savings. They described instances where Army procurement officers had pressured them to accept modifications that Colt's engineers recognized would precipitate problems. Internal Colt memoranda submitted to the committee revealed that the company had anticipated extraction failures months before their occurrence in Vietnam. Army ordnance officers provided testimony that proved deeply damaging. Under interrogation, they admitted to inadequate testing of the ball powder prior to its authorization for use. They acknowledged the failure to issue cleaning kits or provide training materials to soldiers in Vietnam. They confirmed their promotion of the rifle as self-cleaning, despite lacking any empirical evidence to support this claim. Some officers confessed to personally opposing the M16 and favoring the M14. The subcommittee's report, released on October 19, 1967, comprised nearly 600 pages. Its conclusion was unequivocal. The M16 malfunctions were attributable to Army mismanagement and negligence. The Ordnance Corps had modified the rifle's ammunition without sufficient testing. They had excised critical specifications, such as chrome plating, in pursuit of cost reduction. They had failed to supply soldiers with necessary training and maintenance equipment. They had disregarded warnings from both the rifle's designers and its manufacturer. The report employed language rarely found in congressional documents, asserting that the failure to implement corrective measures bordered on criminal negligence. The ensuing scandal prompted immediate remedial action. The Army rapidly expedited the production of chrome-plated chambers and bores. They reverted to utilizing an improved powder for M16 ammunition. They manufactured millions of cleaning kits and distributed them to every soldier serving in Vietnam. They developed an instructional manual, presented in a comic book format, detailing rifle maintenance procedures. They instituted mandatory training programs focused on M16 upkeep. 10 modifications were implemented in the rifle's design, resulting in the M16A1. The revised rifle was officially standardized on February 28, 1967, superseding the earlier XM16E1 designation. The M16A1, featuring a chrome-plated chamber, appropriate ammunition, essential cleaning equipment, and adequately trained personnel, proved to be as dependable as its designer had consistently maintained. By the conclusion of 1968, the malfunction rate had decreased to levels comparable to any military rifle. Soldiers who received the updated M16A1, accompanied by proper training and cleaning supplies, found it to be an exceptional weapon. It was light, accurate, manageable, and, when meticulously maintained with the correct ammunition, entirely reliable. The rifle began to garner respect on the battlefield. Soldiers valued the ability to carry 300 rounds compared to the 140 rounds of M14 ammunition. They found the rifle easy to handle in the close-quarters combat prevalent in Vietnam. They discovered that the small, high-velocity bullet proved devastatingly effective against enemy personnel. The M16A1 continued its service throughout the remainder of the Vietnam War and became the standard rifle for all branches of the United States military. By the 1970s, it had been adopted by numerous allied nations. By the 1980s, millions had been produced. The rifle underwent continuous evolution. The M16A2, introduced in the 1980s, incorporated a heavier barrel, enhanced rear sights, and a brass deflector to safeguard left-handed shooters. The M16A4, unveiled in the 1990s, featured a flat-top receiver equipped with a Picatinny rail for optics mounting. In 1994, the military introduced the M4 carbine, a more compact variant featuring a 14.5-inch barrel and a collapsible stock. The M4 would eventually supplant the M16 in most frontline units, becoming the standard infantry weapon. However, both firearms retained the original design principles: the gas system, the straight-line stock, the aluminum receiver, and the modular construction. The innovations conceived in a Long Beach garage during the 1950s remained the bedrock of America's military rifles 70 years later. Eugene Stoner did not cease his work with the AR-15. In 1961, after Armalite transferred its rights to Colt, he departed to serve as a consultant for Colt. He subsequently moved to Cadillac Gauge, where, between 1962 and 1963, he engineered the Stoner 63 weapons system, a modular design adaptable as a rifle, carbine, or light machine gun. The Stoner 63 was adopted by the United States Navy SEALs and saw limited deployment in Vietnam. Approximately 4,000 units were manufactured between 1963 and 1971. This weapon showcased the designer's ongoing innovation, though it never achieved the widespread acceptance of the M16. In 1971, he co-founded Ares Incorporated in Port Clinton, Ohio. At Ares, he developed enhanced versions of the Stoner 63, designated the Stoner 86. He also explored advanced concepts that were decades ahead of their time. He experimented with polymer ammunition, aiming for further weight reduction. He developed telescoping cartridges that would permit a greater number of rounds to be housed within a magazine. He worked on caseless ammunition systems. These concepts, deemed too radical in the 1970s, would later influence rifle development in the 21st century. In 1990, at the age of 67, Eugene Stoner joined Knight's Armament Company in Titusville, Florida. There, he designed the SR-25, an enlarged iteration of the AR-15 chambered for 7.62 mm NATO ammunition. The SR-25 combined the precision of a sniper rifle with the dependability and handling characteristics of the M16. It was adopted by the United States Navy as the Mark 11 Mod 0 sniper weapon system. Navy SEALs utilized the rifle in Iraq and Afghanistan, commending its accuracy and reliability. It represented one of the designer's final achievements and one of his most distinguished. The SR-25 demonstrated that the fundamental AR-15 design could be successfully scaled for larger cartridges, validating concepts he had initially explored with the AR-10 40 years prior. In May 1990, Eugene Stoner met Mikhail Kalashnikov, the designer of the AK-47, for the first time. The two legendary firearms designers, whose rifles had armed opposing forces in every major conflict since the 1960s, convened in Washington. They toured the National Rifle Association's National Firearms Museum together, examining each other's designs displayed side by side. They engaged in shooting activities at a range in Virginia, each firing the other's weaponry. They visited the Marine Corps base at Quantico, where they observed testing of new armaments. By all accounts, they developed a friendship during those few days. Two designers who understood that they had both striven to resolve similar challenges, albeit from distinct philosophical perspectives. Kalashnikov prioritized simplicity and ruggedness above all else. Stoner emphasized lightness and precision. Both succeeded in creating firearms that would serve their respective nations for generations. Eugene Morrison Stoner succumbed to cancer on April 24, 1997, at the age of 74. He was engaged in firearms design work in his Florida garage when his health deteriorated to the point where he could no longer continue. He was interred at Quantico National Cemetery in Virginia, among the Marines with whom he had served more than half a century earlier. He was survived by his wife Barbara, whom he married in 1965, 4 children from his initial marriage, 7 grandchildren, and 4 great-grandchildren. He left no substantial estate. Despite designing the most widely produced military rifle in American history, he had never amassed considerable wealth. The licensing agreements that provided him with royalties were modest, and he dedicated his life to working for companies rather than owning them. He passed away as he had lived, quietly pursuing the problems that captivated him, eschewing publicity, allowing his designs to speak for themselves. The rifle he designed has become the most contentious firearm in American history. Over 30 million AR-15s, the civilian semi-automatic variant of the M16, are now present in American homes. They have become a symbol of gun rights for some Americans and a symbol of gun violence for others. 10 states have implemented varying degrees of restrictions or prohibitions on AR-15 style rifles. The debates persist, passionate and unresolved. His family has publicly stated that he designed the AR-15 as a military weapon, not for civilian use, and that he would have been horrified by the weapon's association with mass shootings. Conversely, others contend he would have supported civilian ownership of his design, citing his work on civilian firearms throughout his career. The truth, much like many aspects of the man, is likely more nuanced than either side acknowledges. What remains beyond dispute is the rifle's military significance. The M16 family of rifles has seen service in every American military conflict since Vietnam. It has armed American soldiers in Grenada, Panama, the Persian Gulf War, Somalia, Bosnia, Kosovo, Afghanistan, and Iraq. It has been adopted by more than 80 nations. It has been manufactured under license by South Korea, Singapore, and the Philippines. It has inspired countless imitations and derivatives. The Taiwanese T-65, the Canadian C-7, the British L-85A1, and dozens of other rifles trace their lineage directly to the original designs. The rifle fundamentally altered modern infantry tactics. Prior to its adoption, infantry combat doctrine presumed soldiers would engage adversaries at distances ranging from 400 to 600 yards. The M16's projectile, designed for engagement distances under 300 yards, necessitated a fundamental reevaluation of infantry combat strategies. Consequently, military planners embarked on developing novel tactics centered on dynamic movement, sustained suppressive volleys, and swift offensive actions. The contemporary nature of infantry engagements, characterized by a premium on speed and overwhelming firepower, was intrinsically linked to the M16's successful amalgamation of reduced weight and an elevated firing cadence. Beyond its combat applications, the rifle also profoundly reshaped military logistical frameworks, a facet often overlooked. The reduced mass of 5.56 mm cartridges compared to the 7.62 mm NATO rounds permitted soldiers to transport a greater quantity of ammunition without increasing their load. This enhancement enabled infantry units to maintain sustained firing operations for extended durations, even during protracted deployments far from established supply depots, conferring a decisive strategic edge. The M16's featherweight construction, coupled with its ammunition efficiency, paved the way for modern aerial assault operations. Soldiers could be rapidly deployed via helicopter, equipped with sufficient ordnance for prolonged engagements, a capability previously unattainable with bulkier weaponry and its associated heavier ammunition. The gas operation system, a pioneering element of its design, subsequently became the benchmark for modern military firearms. While certain weapon designers still favor piston-driven mechanisms, the majority of current military rifles employ variations of this direct impingement gas system. Its inherent simplicity, minimal weight, and commendable reliability when subjected to proper maintenance have proven exceptionally difficult to eclipse. Indeed, even firearms that appear substantially dissimilar frequently incorporate design philosophies that were initially showcased in the AR-15 platform. Eugene Stoner's narrative fundamentally challenges prevailing assumptions regarding firearm development and military acquisition processes. He lacked any formal engineering education beyond secondary schooling, acquiring his expertise through practical experience within aircraft manufacturing facilities and machine shops. His innovative weapon designs originated not in government research facilities, but in the humble setting of his own garage. He dared to question established doctrines that his contemporaries accepted without reservation. His success stemmed from a willingness to embrace unconventional thinking, to utilize materials others dismissed, and to challenge the pronouncements of experts who deemed his concepts unfeasible. The Army ordnance officers who initially opposed his rifle possessed decades of battlefield and design experience. They held engineering degrees from esteemed institutions and had contributed to the development of weapon systems deployed in 2 global conflicts. They were firmly convinced that a self-taught machinist from California could not possibly possess superior knowledge of rifle design compared to their collective expertise. Their conviction was misplaced. Their hubris, their unyielding refusal to consider the possibility of error, tragically resulted in the loss of American lives in the dense jungles of Vietnam. The widespread issues encountered with the M16 in 1967 were not attributable to inherent design flaws. Instead, they were a direct consequence of military administrators who altered the rifle's specifications without a comprehensive understanding of its intricate workings, who disregarded the cautionary counsel offered by both the designer and the manufacturer, and who prioritized institutional prestige above the safety of the warfighters. The subsequent congressional inquiry revealed that Army officials vested with authority had failed to implement corrective measures for known deficiencies, a dereliction of duty that verged on criminal negligence. Despite this damning indictment, no individual faced repercussions. No court-martial proceedings were initiated. No commanders were removed from their posts. The entrenched organizational culture that precipitated the crisis remained largely unaltered. Although subsequent investigations and reforms did refine military procurement procedures, analogous challenges have continued to manifest. The crucial lesson that innovation can emerge from unanticipated sources and that expertise should be recognized irrespective of its origin remains a difficult principle for large organizations to internalize. The M16's tumultuous introduction into military service serves as a stark reminder of the perils of bureaucratic arrogance and the paramount importance of heeding the insights of designers and engineers who possess a deep comprehension of the systems they conceptualize. Eugene Stoner never achieved the widespread recognition of figures like Thomas Edison or Henry Ford. The vast majority of Americans who own AR-15s are unaware of his name. Most soldiers who wielded M16s in Vietnam never learned the identity of the individual responsible for the firearm that both preserved and claimed their lives. Throughout his life, he maintained the persona of a quiet, unassuming engineer who found greater comfort in the environment of machine shops than in corporate boardrooms. He actively shunned the limelight and rarely granted interviews, preferring to let his creations speak for themselves. When reporters did manage to engage him in conversation, they encountered a man of soft-spoken demeanor, more inclined to discuss technical intricacies than to claim credit for his accomplishments. Yet, his enduring impact is undeniable. A visit to any American firearms retailer will reveal numerous AR-15 variants. Military installations showcase soldiers training with M4 carbines, direct descendants of his revolutionary design. Infantry tactics manuals from modern armies routinely outline doctrines that presuppose soldiers are equipped with firearms possessing the characteristics inherent to the AR-15. His rifle has effectively established the standard by which all other infantry firearms are evaluated. Nations developing new military rifles invariably benchmark them against the M16. When soldiers engage in discussions about the merits of various armaments, the M16 serves as the foundational point of reference. The statistical data attests to its unparalleled success. Approximately 8 million M16 rifles have been manufactured for military deployment globally. The M4 carbine, a direct descendant of the M16, has been produced in additional millions. Over 30 million AR-15 rifles have been acquired by civilian consumers in the United States, cementing its status as the most prevalent rifle platform in the nation. The rifle has been produced in over a dozen countries, seen service in more than 100 conflicts, and armed military personnel from over 80 nations. It has served as the primary infantry weapon for the United States military for more than 60 years, a tenure exceeding that of any other rifle in American history. Furthermore, there is no indication that it is nearing obsolescence. The United States Army has initiated several programs aimed at replacing the M16 and M4 with new rifle designs. Each initiative has concluded that no currently available alternative design offers sufficient advantages to warrant the substantial financial investment required for a transition to a new weapon system. The most recent undertaking, the Next Generation Squad Weapon Program, has yielded a new rifle. However, a complete replacement of the M4 is likely decades away, if it materializes at all. The M4 carbine is expected to remain America's principal infantry rifle for the foreseeable future. Eugene Stoner demonstrated that an individual, driven by tenacity and intellect, possesses the capacity to profoundly alter the world. He proved that formal academic credentials are not a prerequisite for groundbreaking innovation. He showed that challenging established norms can lead to breakthroughs that elude even seasoned experts. He validated the efficacy of lightweight materials and unconventional approaches where traditional methods faltered. And though he did not live to witness its complete fruition, he proved that superior engineering will ultimately triumph over bureaucratic obstruction and institutional inertia. The rifle they claimed could not be fabricated became the weapon that defined contemporary infantry combat. The machinist they deemed unqualified designed the firearm that experts continue to find inimitable. The young man who could not afford higher education developed technology that irrevocably shaped military history. Eugene Morrison Stoner, born in a small Indiana hamlet during an economic downturn, passed away having achieved his ultimate objective: the design and construction of the most effective infantry rifle the world had ever witnessed. The fact that the transition from a garage workshop to a military standard required decades, congressional investigations, and numerous formidable obstacles only amplifies the magnitude of his accomplishment. The rifle that was universally deemed unmakeable against all odds and expectations became America's rifle.